Hello class, welcome to the next segment in the week 4 material, and in this segment we're going to take a look at something that's a little bit more abstract, but it is something that can actually be useful to you if you choose to employ the tools that we're about to introduce here. So up until this point, when we've been working with a variable in Python, we've primarily been working with variables that have been holding on to some sort of numerical value, whether that's an integer or what's referred to as a floating point number, which is a number that has decimals in it. But it also turns out that variables can hold on to what's referred to as a Boolean, which is basically a binary value. It's either false or a value of true. And we have some examples of that here on line 2. And essentially what these do is these can be put in place of the conditions that you have in an if statement. So if we take a look at to sort of get an idea of what is going on here, let's go ahead and take a look back at something that we had earlier. So this is what we had when we were first introducing the OR statement. And the way that the computer actually is reading this off is it's first testing this condition, and it will then replace that entire condition with a value of either true or false. It'll be assigned a value of true if the condition is met. If the condition fails, then it'll be assigned a value of false. And it does that for every one of these conditions. So what you actually end up with is you have, in this particular case, we have a value of true and a value of true over here. And if there's just one true on either side of the OR operator, then the computer considers the entire thing to be met or true. And the whole idea behind a Boolean variable is it allows you to replace these conditions with individual variables. So rather than asking if x is equal to 10, if x is a numerical value, you could assign x to be a Boolean value, that is a true or a false, and that will automatically assume a value sort of like what you see here on line 5. So if you end up with a Boolean variable whose value is true on one side of the OR and another Boolean variable whose value is true on the other side of the OR, then the computer is just going to read that off as any true condition or any true condition, which the answer to that entire thing is going to be yes. If you have just one true condition involved in the OR operator, then the answer to the entire question is true. So this might seem kind of confusing at first, and you might be wondering why in the world we would want to do something like this, but there are actual uses to this, and not something that we're going to heavily emphasize in this class, but if you take some more advanced programming classes, this is going to be a concept that they expect you to know. So if we continue on, we have, if we continue on with the examples that we have here, so here we have a condition that is met, so the computer will replace this entire condition with a value of true, and we'll replace this entire condition with a value of false since that fails. And since we require only one true in the OR statement, whether that's over here or over here, we require just one of those things to be true in order for the entire thing to be true. And in the case of this particular condition down here, here we have a condition that gets replaced with a value of false because this condition fails. This condition also fails, so it gets replaced with a value of false. And since we have two falses on either side of the OR operator, then that means the entire thing just fails. Since we need one of these to be true, and since none of them are true, we need at least one of these to be true, and since none of them are true, then the entire thing just fails. And we can go through the same exercise by looking at the AND statement. So if we have a true on both sides of the AND, then the entire thing is met. But if we have a false anywhere in the AND, then on either side of the AND, then the entire thing just fails. So again, the computer just goes through, tests each one of these conditions, and the condition itself is replaced with a value of either true or false. And it will do that process for each condition that appears in your program. And if you have a true appearing on both sides of the AND, then the entire condition itself is met, and it's something the computer will run an ended statement on. But if you have a false on just one side of the AND, then the entire condition is going to fail. So in this case, we have two falses that appear on both sides of the AND. But that's just sort of a behind-the-scenes look of what the computer is actually doing here. It's taking each individual condition, assigning it a value of true or false, depending on if it's met or if it fails, and then it's going to compare the trues and the falses, and from there it will determine if the entire condition is met or if the entire condition fails. But if we want to assign a value of true or false outright, then we can actually do that and store it in a variable here. So in this case, we have a variable x, which is going to just take the place of a condition that is always going to be true. And in the case of this variable y, this is going to take the place of a condition that is always going to be false. And this variable z is going to, just like x, take the place of a condition that is always going to be true. So think for a minute to sort of help you understand what exactly is going on here. Think about this. If we take a look at this condition here on line 6, where we have if x or y, imagine for a minute just any condition that is true on the left-hand side of this or, again, true being correspond to the value of x itself. And then on the other side of the or, imagine having a condition that is false. So again, the false corresponding to the value of y that we have up here. So this sort of has the computer test this out as if there were a true condition on one side of the or and a false condition on the other side of the or put in more layman's terms, it's testing if there's a question over here that the answer is yes to, and there's a question over here that the answer is no to. But in the case of the or operator, we require at least one of those to be true in order for the entire thing to be true. And since we have what is more or less a true condition on one side of the or, an answer of yes on one side of the or, then in this case, this entire condition on line 6 is in fact true. And if you want to tie this back to something that we had earlier, this is basically going to be the same thing that we have here, except here we're just outright stating the values of true and false to the computer, which they can then act on. So we've kind of removed this intermediate step from the computer. So instead of the computer itself taking these conditions and converting them into trues and falses, we can actually do that process ourselves if we so wanted to, and just get the computer to read this off as just any condition that's always true and any condition that's always false, and then it will act on the ors and ands appropriately, and then it will act on the if statements appropriately, just like any other if statement. So since I have something that's essentially a true condition on one side of the or here and a false condition on one side of the or on the other side of the or, we require just one of those to be true in order for the entire thing to be met, or for the entire thing to be true. So in this case, this condition up here, this entire condition in the if statement is met, so that means the computer will in fact act on it. It will in fact run this indentation that appears on line 7. And if we take a look here at line 9, so here we have, again, on this side of the and, you can think of that as a condition that is always going to be true, since x is true in this case. And on the other side of the and, you can think of this as a condition that is always going to be false, since we've set y to be equal to sort of we've allowed y to sort of represent a condition that's always false. That's the whole idea behind a Boolean. That's the whole idea behind a Boolean variable. You define a variable and basically set it equal to a condition that's always true, or to take the place of a condition that's always true. Or in the case of y, we've set that equal to we set that equal to a value that will sort of take the place of a condition and always treat that condition as something that's false, a condition that always fails. So if we have a condition that is always met on one side of this AND operator on line 9, again, that's given by the value of x up here, and we have a condition that always fails, and that's, again, given by the value y up here, since we require both of these conditions to actually be met, or if both of those things to actually be true, then this entire condition on line 9 fails. So that means the computer is just going to skip over this indentation. Again, like any other if statement, it's going to skip over that indentation that appears on line 10. And we can also, up until this point, we've only been looking at an if statement that had just one instance of or one instance of and. We haven't been looking at what happens when we combine both of those things. But I'll go ahead and sort of emphasize best practice. If you're going to include ands and ors as part of a larger question in a single if statement, then I strongly recommend using parentheses to make sure the computer is evaluating things in the order that you want them to. So just like regular algebra, the computer is going to evaluate the innermost set of parentheses first, which are the ones highlighted in green here, and then it will continue evaluating from there. So in this particular case, it's going to first evaluate this, in this case, Boolean expression, conditions x and z. And once it's done doing that, it will take that result and check it against the or y that appears after that. So whatever questions you want the computer to ask first, make sure those are in the innermost set of parentheses. So again, this goes back to idea between order of operations. You want to use parentheses to make sure the computer is doing things in the order that you want them to. The same thing also holds whenever you're getting the computer to ask a whole bunch of questions in a single if statement. You want the computer to be asking the questions in the order that you want it to, and the best way to accomplish that is to use parentheses so that you can make sure the computer is checking the conditions in the order that you want it to, so that you're not getting errant results that you don't want. So anytime you have ands and ors in the same condition or in the same if statement, parentheses are your absolute best friend that you want to treat very well and make sure you're well acquainted with. So kind of extending on that a little bit further. So here we have the variable x and the variable z, which again are just taking the place of a condition that's always true. So we have a true and a true. So we have true on both sides of the and here. So that means this entire thing is true, everything that's highlighted. And then we have a true on this side of the or here, and we have a false on the other side of the or. But in the case of the or, we only require at least one thing to be true in order for the entire thing to be true. So that means we expect this entire condition in this if statement to actually be true, which means we're going to run what's indented below that, in this case printing out x, z, y. And if we take a look at what's on line 15, asking if x, so here we have x and y, so we have a condition that is met, again represented by the variable x up here, and a condition that's not met, represented by the variable y up here. So that means we have a condition that is true and a condition that is false. So, and we have an and there, so that means both are false. So, or the entire thing, this entire thing in the parentheses is false. Since and requires both of these things to be true, and since only one of them is true, then the entire thing is false. So we have a false here on a false condition on the left-hand side of the or, but we have a true condition on the right-hand side of the or. And again, or requires just at least one of them to be true in order for the entire thing to be true. So that would then stand to reason that this entire condition on line 15 is in fact true. That condition is in fact met. So we should expect to see 3 print statements if we were to go to run this right now. And you can see we do in fact see that exact result. So this whole idea behind using a Boolean variable, it might take some getting used to. So if you need to rewatch this video to sort of get a better idea of what exactly is going on, then by all means, I encourage you to do so. One other thing, again, I'm going to be, when I introduce this, I'm going to be operating under the assumption that you have a fairly good understanding of what's going on already. But it's also entirely possible to do something like this. So this kind of goes back to what we started with at the very beginning. We can have a variable sort of represent the end result of a particular condition. So in this case, we're going to evaluate what's on the right-hand side here, ask if a is in fact equal to 10, and if it is, then this entire result on the right-hand side will in fact be a value of true. Sort of like what we have here on line 6, but in this case for the variable z. And if this condition on the right-hand side fails, then x will assume a value of false, sort of like what we have here for y on line 5. So your variables, again, this is something that's kind of abstract, something you may or may not get a lot of use out of, but you can also have your variables hold on to the result of a particular condition. And I could even go so far as to do this if I really wanted to. So if this entire condition on the right-hand side is true, if that is in fact satisfied, then the variable x itself will hold on to a value of true, much like our variable z here on line 6. But again, if this seems confusing at first, then try rewatching the video and making sure you understand what's going on in each step of the way. If not, then don't hesitate to ask me questions. But that's going to do it for this segment on the idea of a Boolean variable. And in the next several segments, we're going to start talking a little bit about the applications of Boolean logic and what we've been talking about. So with that, I will see you all in the next segment.